Hello and welcome to the Unit 3 review video. So this is being redone in 2022. So if you're watching in future years, what's the future like? Let us know. So I'm just going to scroll through and show you which problems I'm going to be doing. So I tried to pick a variety. So we've got 1, 2, 3, 6, 8, 14, 15, 16, 19, 25, 27, 28, 29, 30, and 33. So that should be a good variety. I'm going to go back to the beginning. Okay, so starting with number 1, some multiple choice practice. Whenever we ask you to simplify, we're always looking for you to factor first where you can. So for instance, the numerator there has a GCF of x. Denominator has a GCF of 5x. Oops, 9 minus x. Okay, now from there, a couple things cancel. X's cancel, and x minus 9 and 9 minus x cancel, but they cancel to a -1 because they're opposites with subtraction. Now remember, canceling means reduces to 1, so this is equal to -1/5, and that's option C. Okay, moving on to number 2. Whenever we're adding or subtracting fractions, we need to have a common denominator. So you should factor the denominators first to see what they're made of. So 2y minus 3 for that first. Now, recognizing that my common denominator is 1 of everything I see, I'm going to want a 2 and I'm going to want a y minus 3. So this first fraction actually has the common denominator, so he's fine. So 3y over 2 times y minus 3. The second fraction, though, which is y over 2, I'm going to say he needs a y minus 3. Now remember, whatever you do to the bottom, you have to also do to the top. Now, once I have this as two fractions with the same denominator, I can combine the numerators. So 3y minus y times y minus 3 all over your common denominator. Now remember, you cannot cancel here. Of course that matches. You introduced it here. You need to clean up that numerator and combine like terms. So I have 3y minus y squared plus 3y all over your common denominator. 3y and 3y is 6y, so this is 6y minus y squared all over 2 times y minus 3. Now if you look at your options, okay, it's definitely not A, definitely not B. Now you're between C and D. There's that 6y minus y squared and 2 times y minus 3. That's your correct answer at D. Now for question 3, whenever you have a radical equation, you want to isolate the radical, meaning get him alone, and square both sides. Good news here is that it already is alone, so you can go ahead and square both sides. So we get 9x plus 10 equals x squared. Now because it's a quadratic, we're going to want to set it equal to 0. Using my AM factoring techniques, I'm going to want 10 and 1, but a -10 and a +1, and x equals 10 and x equals -1. Now you have to be careful here, okay? You always, always, always need to make sure you check to see if anything will reject. So if I grab my calculator, okay, let's say I want to check 10. I'm going to store him as x. Okay, type in the left side of the equation, radical 9x plus 10. That reduces to 10, which is the same thing as x, so that checks out. Let's do the same thing, but store -1 as x. Copy that expression again, so I'm substituting in -1 for x, and I got +1, not -1 as it should be with the equation, which means this rejects, and your final answer is x equals 10. So again, make sure you guys always check in these radical equations. All right, lastly on this page, question 6. This is a complex fraction. Now, depending on who your teacher is, you might get a different method. So the first way I'm going to go through is the way that me, Mrs. Pollard, and Ms. Costanzo teach it. The second way I'll go through it is how Mrs. Putzer teaches it. So let me zoom in here. Okay, first thing first, and we actually all do this the same. I'm going to put this over 1. Any little floater guys, turn them into fractions. And then decide on your common denominator. So common denominator in this case would just be x. I'm going to make everybody have the same common denominator. So he needs an x, he's fine. He needs an x, he's fine. And by doing that, that creates an x squared over x minus 1 over x all over 2x over x minus 2 over x. So everything has the same denominator. Now, technically what's happening here is you've actually created a single fraction in the numerator, whether you've realized it or not, because you have a common denominator. Same thing in the bottom, 2x minus 2 all over x. Now, to over-explain this, using keep, change, flip, I can technically rewrite this as times x over 2x minus 2, and the x's would cancel, and you'd have x squared minus 1 over 2x minus 2, and that's why that works. Now, instead of writing it as keep, change, flip every time, I'm just recognizing that these denominators would reduce because of keep, change, flip, which I showed down here, and you end up with, in the numerator, x squared minus 1 over 2x minus 2. So usually Ms. Costanzo and I, we skip this middle step right here and we'll just cross them off right there. And we'll get x squared minus 1 over 2x minus 2. But again, that's the whole over explanation of why this works. Now that I have it written as a single fraction, I can factor the top to x plus 1, x minus 1, and the bottom to 2 times x minus 1. X minus 1's cancel, and we end up with x plus 1 over 2. So if I zoom right back out, x plus 1 over 2 is option A. Now I'm going to keep doing this problem because I'm going to do it the way Mrs. Putzer does it now. So let me erase. Now, what Mrs. Putzer does is actually really similar. She recognizes that she's going to turn those into fractions, and the common denominator among all of those would be x. But instead of manipulating the fractions that don't have the common denominator, she's just going to multiply everything by that denominator. So she's going to multiply everything by x over 1. And by doing so, she creates essentially 4 little mini multiplication problems, which is why she calls this the box-it method. So in the upper left, she just has an x squared over 1, which is just x squared, minus. Now, when you multiply 1 over x by x over 1, the x's reduce, and you'd get 1 over 1, which is 1. Bottom left, you have 2 times x over 1, which is just 2x. Bottom right, x's cancel, and you end up with a 2. And this is actually exactly where Ms. Costanzo and I were at after getting common denominators and canceling them. Same thing, x plus 1, x minus 1, 2, x plus 1, x minus 1. X minus 1's cancel, and you still end up with x plus 1 over 2. So no matter who your teacher is, sometimes Mrs. Marin teaches this course and she does keep, change, flip. That's 3 different methods right there. You'll get the same answer. Okay, now if you're a Pollard or Costanzo student, I probably wouldn't switch up your method right now, but those are the 2 solutions. All right, coming to question 8. So whenever you see a negative exponent, that means that you will flip the fraction and raise it to the positive 1 instead. So that means this is x squared minus 4 over x minus 3, technically raised to the positive first power, times the second fraction. Now again, anything raised to the first power is itself, so I'm actually just going to erase that positive 1. Now you're set up just to factor and solve. You've got x plus 2, x minus 2, little am factoring on the right, Okay? Now, once you have everything factored, remember you can cancel anywhere in the problem as long as it's one numerator with one denominator. One numerator, one denominator. And you'll notice I end up with then x plus 2 times x plus 2, or x plus 2 squared if you want to write it that way. And that's the final answer to 8. All right, question 14. You're adding or subtracting fractions. You need a common denominator. Factor it to see what they're made up of. And then take one of everything you see. So I'm going to take an x, and I'm going to take an x minus 1. So that means the second fraction has the common denominator, but the first one's going to need an x. So you have x times x plus 3 all over x times x minus 1 minus 4 over x times x minus 1. Once you have common denominators, you may now combine the numerators. So I have x squared plus 3x minus 4 all over your common denominator of x times x minus 1. Factors of negative 4 that sum to a positive 3. So x plus 4, x minus 1. Oh, hey, look at that. Your x minus 1's cancel. And so our final answer is x plus 4 over x. Now remember, we talked about how when there's addition, these terms are glued together. You're not going to slash or cross out those x's or chop them, some teachers call it, because these are bound together with the addition. Okay? These are together over x. Final answer. All right, come on down to question 16. When I ask for restrictions on the domain, I'm ultimately just asking where this function is going to be undefined. Undefined has to do with the denominator. So if I set the denominator equal to 0 and solve, this would be y plus 2, y plus 1, y equals negative 2, and y equals negative 1. Those are your restrictions. So we're saying y cannot be negative 2, y cannot be negative 1 as your restrictions. Okay, working backwards to question 15. Now we're dealing with an equation. So similar to adding and subtracting fractions, you want common denominators. So factor to see what each is made up of. So that's dots. Now, recognizing that I want to take one of everything I see, you're going to want a y plus 2 and a y minus 2. That means the first fraction is going to need a y plus 2. Second fraction needs a y minus 2. And the last fraction has the common denominator, so you're good. So let me rewrite this. I have y times y plus 2 all over my common denominator, plus y plus 1, y minus 2 all over the common denominator, and 2y minus 1 over our common denominator. Now at this point, because all of your denominators are the same, it makes sense that the only thing you then need to solve is the numerator. So this is where we say if the problem equates, you may drop the base and solve the numerator. So it's not that the base isn't important. We'll come back to it later. It's just not going to be necessary to our solving for what y is because it's an equation. So if I look at the numerator and do some distribution, I get y squared plus 2y. Do a little foiling here. Y squared minus 2y plus y minus 2, and then equals 2y minus 1. Okay, combine your like terms. So y squared and y squared is 2y squared. 2y minus 2y would drop out and go to 0, but then you have a plus y minus 2. Now don't forget you're going to want to subtract the 2y. So y minus 2y is minus y, and then add over the 1. All right, let's try to factor solve this. So if I draw my triangle, that's 2 times negative 1, which is negative 2, and factors of negative 2 that sum to negative 1 are negative 2 and 1. So this is 2y squared minus 2y plus 1y minus 1. And then I can do factor by grouping. And then solve. Y equals 1. Y equals negative 1/2. Now, whenever you're solving rational equations, you need to make sure that your answers don't cause any denominators to go to 0. So for instance, if I take the 1 and plug them into any one of these denominators, it's not going to cause a 0. Same thing with the negative 1/2. In fact, the only values of y we can't have here, because it would cause the denominators to go to 0, would be plus or minus 2. So those solutions didn't come up, so we're good. Those are your two answers. All right, taking a look at question 19 now. This one is tricky just because those denominators look super similar, but not quite exactly the same. You have to remember that addition's commutative, but not subtraction. But here's what I can do. I can make these denominators look the same by multiplying top and bottom of the second fraction by negative 1. So watch what happens here. This would create a negative 14 and then technically a negative 7 plus y by doing my distribution. Now, isn't negative 7 plus y the same thing as y minus 7? Look at that. Now I have the same denominators. Now, do not drop denominators. Whoops. Whoa. Hold on a second. There we go. Do not drop the denominators here. This is an expression, not an equation. So this is not when the problem equates, drop the base. This is simply just a simplify. So now that I have the same denominators, keep the denominators and add the numerators. Now from there, I'm noticing there's a GCF of 2. And oh, hey, look at that. Y minus 7's match. So this whole thing just reduces to 2. And that's a final simplified answer. All right, moving on to question 25. This is a rational equation because there's an equal sign. So this is going to be one of those when the problem equates, drop the base, but you're going to need a common denominator first. So let's put everything over 1. There's nothing to factor, but I can see my common denominator would be everything I see. So 2 times x plus 1. So that means, let me actually write this bigger so I easily can write here. Okay, that means the first fraction is going to need both an x, or both a 2 and an x plus 1. But whatever I do to the bottom, I have to also do to the top. Start from the bottom, see what he's missing. He's missing an x plus 1. So next guy is missing a 2. Last guy is missing a 2 and an x plus 1. Okay, so once you've adjusted all the numerators accordingly based on what the denominators were missing, we can now say when the problem equates, we can drop the base and solve the numerator. So I've got 2x times 2 times x plus 1, that's just from here, minus 5 times x plus 1 equals, now careful, that's not an exponent, this is 2 times x minus 1 plus 2x times x plus 1. All right, holy cannoli, this is a lot going on. All right, so something to notice is that this is technically 4x, and I can distribute him. So that's 4x squared plus 4x minus 5x minus 5 equals 2x minus 2 plus 2x squared plus 2x. This is going to have a lot of work. I think we're going to have to show some work into the mic problem, so bear with me here. All right, combine my like terms. I see some x's I can combine on either side. So this is 4x squared minus x minus 5 equals 2x squared plus 4x minus 2. And now let's set it equal to 0 because it's a quadratic equation, meaning it's an x squared. So if I subtract the 2x squared, that would leave me with 2x squared. If I subtract the 4x, that would give me a minus 5x. And if I add the 2 over, that would give me a minus 3. All right, let's see if this factors. So 2 times negative 3 is negative 6, and factors of negative 6 that sum to negative 5 are negative 6 and 1. So this is 2x squared minus 6x plus 1x minus 3. So this factors to 2x plus 1, x minus 3. Now remember, you're looking to factor solve this. So if I tee it up, I would get two solutions, x equals 3 and x equals, subtract the 1 divided by 2, negative 1/2. Now again, you got to go back and double check. Oopsies. Will those cause any denominators to go to 0? In this case, they do not. So therefore, those are your final answers. But again, I did check to make sure any denominators didn't go to 0. All right, so I want to do question 27, but I kind of worked into this space. So I think what I'm going to do is I can actually move my work. I'm going to move him up here, I think, off to the side. Look at that. Perfect. Just moved it out of my way. All right, so on to the Mike mixture problem. Mike isn't paying attention and creates a 16-ounce protein shake with 50% water and 50% protein powder. How much liquid does he have to add to the shake to make the water to powder ratio 3:1? All right, so first of all, a 3:1 ratio means there's 4 total parts. And if it's water to powder, that means they're saying the water is the 3 out of 4 total, which is really 75%. So he wants the ratio to be 75%. He's at a 50% ratio right now, or 50% water right now. So this is where we set up a table. He has 50% water. He wants to add water, which is 100% pure water, to create a mixture that's 75% water. All right, so those are the percentages we're dealing with. You've got amount, percent, and total for the tops of your columns. Now, remember he's starting with 16 ounces of the 50% water protein shake. How much liquid would be your x? So how much water does he have to add? Which means if you have 50% water and you're adding 100% more, it would be x plus 16 for the total for the 75% mixture. Fill in the decimals and multiply across. So 0.5 times 16 is 8, 1 times x is x, and this is 0.75 times x plus 16. Now you're adding these first two together to create the mixture that's 0.75. So we have 8 plus x equals 0.75 times x plus 16. Now from there you could do this in terms of the decimal, but I like to get rid of that 0.75 by saying, okay, I can multiply by a number that would make that decimal move 2 places over. And so hopefully you know that would be 100. It's equal to the number of zeros that it will move. So that means you would get 800 plus 100x equals 75 times x plus 16. And now you don't have to worry about decimals. Do a little solving, a little cleaning up here. 75 times 16 is 1200. So 25x equals 400. So if I do 400 divided by 25, we get 16. So he would have to add 16 more ounces of water in order to get a 75% amount of water in his protein shake. And that's your answer. All right, I'm almost positive I had this one circled. I think I accidentally erased my circle. So we're going to also do question 28. So Adam walks 2 miles to Tops and gets a ride home in a friend's car. On the trip home, the car moves 10 times faster than Adam's walking speed. If the total time for both trips is 3/4 of an hour, find Adam's walking speed in miles per hour and round to the nearest hundredth. All right, so big sentence here is that the total time for both trips, so between going to Tops walking and then getting a ride home, is 3/4 of a mile, or 3/4 of an hour, excuse me. So I want to write down time plus time equals 3/4 of an hour. Now this is time walking plus time in a car. Now remember how distance equals rate times time. I'm talking about time here, right? Based on this relationship, I know time is equal to a distance over a rate. So write this as d over r plus d over r equals, and I'll just leave that as 3/4. Now you're rereading the problem. What was the distance he walked to Tops? It was 2 miles. Now if he got a ride home, we're assuming that's also 2 miles because it was straight home. What's the rate of his walking speed? Well, it said the car moves 10 times faster than Adam's walking speed. So let's call Adam's walking speed or rate x, which then means 10 times it for the car speed would be 10x. Now that we have that all set up, we're good to go. Get a common denominator. So we could use, let's say, 40x. Okay, first fraction would need a 40. Second fraction would need a 4. And last fraction would need a 10x. When the problem equates, you can drop the base and solve the numerator. So I have 2 times 40, which is 80, plus 8 equals 30x. 80 plus 8 is 88. On the other side, we have 30x. Divide by 30. So if I grab my calculator and do 88 divided by 30, my rounding direction makes sense because it says nearest hundredth, so 2.93 is our final answer. Okay, now it's always good to double check what x represented here. It says find Adam's walking speed. Well, if here's x, x was the rate of him walking. Now, if I wanted the rate of the car, which is technically right here, it would be that multiplied by 10. I didn't ask for it there, but just a little extension. On to the last page here. I actually added question 31 to this mix because I felt that it was a good one to do as well. So really whipping through these problems. Starting with question 29, solution A has 50% hydrochloric acid, while solution B is 75% hydrochloric acid. How many liters of each solution should be used to make 100 liters of a solution which is 60% hydrochloric acid? Okay, so we've got solution A, which is 50%, solution B, which is 75%, and then a 60% mixture. Now this one's a little bit tricky because it's phrased slightly differently. The 100 liters of a solution which is 60% is actually here. So you know you want to end up with 100 liters of a solution. So we don't know how much of A or B exists. So if I call A X, solution B would have to be 100 minus X. So for instance, if this was 10, this would be 90 because that makes 100. If this is 20, this would be 80 because that makes 100. So these are my variable setups. Now for percentages, it's still 0.5, 0.75, 0.6, and then we still multiply across. Now you're adding A and B together to create your mixture of 60%. So I have 0.5x plus 0.75 times 100 minus x equals 60. And I'm personally going to multiply through by 100 because I want to make this decimal go away. So remember, you're just going to move the decimal 2 places. So this would be 50x plus 75 times 100 minus x equals 60, and then add 2 more zeros, so 6,000. Now I don't have to worry about the decimals, and I can just solve. Okay, so I get a negative 25x equals, now if I grab my calculator and do 6, 1, 2, 3, minus 7, 5, 1, 2, I get negative 1,500. Take that and divide it by negative 25, and we get x equals 60. Now, the problem is asking for how many liters of each solution. So keep in mind that if solution A is x, then x would be 60. If solution B is 100 minus x, then 100 minus 60 is 40. And that's how much of each solution you should have. All right, going on to question 30, where it's a little bit of a harder factoring. In the numerator, that looks like you can pull out a GCF of 4a. And in the bottom, this is actually an AM factoring, or you can use guess and check to factor this. So the only way to get a squared is a and a. Now, think of your factors of 9 that sum to negative 6. So that would be negative 3 and negative 3, right? But in order to create a b squared, it must be b and b. From there, look at the top, that makes sense because now a minus 3b matches, and you end up with 4a over a minus 3b. Coming over to question 31, okay, another equation, so we want the common denominator, factor to see what it's made up of. So common denominator would be x minus 6, x minus 2, which means the first fraction needs an x minus 2. Second fraction needs an x minus 6, and the second fraction has all the things. When the problem equates, you can drop the base and solve the numerator. So we have 1 times x minus 2 plus x times x minus 6 equals 4. X minus 2 plus x squared minus 6x equals 4. And now set it equal to 0 to solve. So x minus 6x is a minus 5x. You have a negative 2, but I subtract, so a minus 6. And now this is a nice little AM factoring. Okay. Now remember, with rational equations, you always need to check to see if it causes anything to go undefined. So if you look back at your numerator, or denominators, excuse me, look at that. If you were to plug in 6 in that denominator, that would cause that to go to 0. Likewise, this would also go to 0. Okay? So because that happens, I have to reject 6, and that's what's known as an extraneous solution. It's something that came about algebraically, but I have to reject because it causes the denominator to go to 0 and be undefined. Now, negative 1, no issues. If you plug it in, none of your denominators would go to 0. So therefore, x equals negative 1 is the answer to question 31. All right, we've got one last problem here to go through. So it has multiplication and division in it. These ones are always fun, I think, just because there's a ton of stuff to factor and then you just cancel all the things. So it's worthwhile going through and even just identifying the type of factoring that each thing's going to be. So like for instance, the top here looks like a GCF. This is SOAP. That looks like another GCF. X plus 1's fine. This looks like a GCF I can pull out, and it looks like there's a GCF in the bottom of that guy as well. Now remember, whenever we do division, we're going to change it to multiplication, but then flip the second fraction. And that's where we do keep, change, flip. All right, so a lot of stuff going on in this problem. So let's just start factoring. So in the top here, I can pull out an x cubed. In the bottom, take the cube roots of each. So that would be 2x and 3. And then remember, it goes square, product, square. Now slope comes in with the signs. Same as the original. Opposite, always positive. All right, we're completely factored for that first fraction. Times, now like I said, x plus 1's not anything to factor. That's just that. But in the top, I can pull out a 2. Now, something you may notice as you're going through as well is that this is dots. So I'm actually just going to factor that one step further right above it in the order given. So the ones come first. And now that's completely factored. Times, now remember you're flipping. So in the top here, it looks like I can pull out a 4x squared, but I'm going to write him down here on the bottom because that fraction flips. The 4x squared then leaves me with a, whoopsies, with an x squared, an x, and a minus 2, I believe. And then I start asking myself, does that factor further? Well, factors of -2 that sum to 1. Could I do x minus 1, x plus 2? That would work. So I noticed a little AM factoring in there that worked for me. And then the top, that's where you have the 8x squared plus 12x plus 18. Looks like I can pull, what, 2x out of all of those? So 2x, or excuse me, just a 2. And that's 4x squared plus 6x plus 9. Woo! All right. So I factored all the things, and in some cases I factored twice because I recognized I could go further. Now that this is a multiplication problem, I can start canceling the things. So as long as it's a numerator with a denominator, and it's only one pair, so it's 2 total, you can cancel it. So for instance, I see I have an x plus 2 and an x plus 2 that cancel. X plus 1 and 1 minus x. Those are the same thing. Look at those trinomials, 4x squared plus 6x plus 9. Okay. What else do we got? Ooh, an x minus 1 and a 1 minus x, but those reduce to a -1 because they are opposites with subtraction. So make sure you note that. Now, if it's starting to get a little bit crazy for you, you might want to rewrite it just with what you have so far. So we've got x cubed times 2 times 2. So it looks like we have a 4x cubed in the numerator. In the denominator, it looks like we have a 4x squared times a 2x minus 3. So again, if you're having trouble seeing what I'm looking at, I'm like here, that I didn't cancel, that I didn't cancel. Oop, don't forget the -1. Good thing I checked over my work. So there's a negative in the top there. In the bottom, I didn't cancel the 2x minus 3. I didn't cancel the 4x squared. Now, look at your answer. You got to ask yourself, can you go further? Well, I can cancel 2 x's in the bottom with 2 in the top, so that would leave you with an x to the first. And you can also cancel the 4's. So it looks like my final answer should be -1x or -x all over 2x minus 3. And that is your final answer with all the different factoring techniques. So hopefully this video helped. Full answer key is on Google Classroom. Happy studying.